Thank you for the applause, and I hope you will not be disappointed. Okay, thank you everyone for coming to this workshop. I'm going to skip this page. So for the next 1 hour and a half, I will try to talk to you about how do we try to build machine learning in production? How do we try to run production-grade machine learning pipelines? So just a show of hands, I have two quick questions. So how many of you have already run machine learning in production? Awesome. How many of you found that easy? As expected, no one, right? So I'm here to try to ease your pain and probably give you some solutions for making that task easier. So I'm here today to speak to you about Kubeflow pipelines. So Kubeflow pipelines is a framework to run machine learning frameworks on Kubernetes, which is a framework for managing infrastructure, right? So basically, you get the idea. More seriously, Kubeflow is a curated set of components and tools and artifacts that glued together, they will provide you the foundation to run machine learning workloads wherever you are, right? If you're running on your laptop, in your development environment, or in production, Kubeflow will allow you to use basically the same artifacts and same components so that your life is much easier, and actually to enable you to forklift machine learning code from development to production, right? During this workshop, we will talking about a stack made of 3 layers, right? So there's the application, platform, and infrastructure layer. So if we go from bottom to top, we will use Google Cloud Platform as an infrastructure, but by no means is the only place where you can run the code that I'm demonstrating today. You can also run it on other cloud providers if you want, or on your own data center. The platform that we'll be using to run machine learning workloads is Kubeflow. And the application, the machine learning application we'll be building is, probably everyone knows this, GitHub issue summarization, right? So it's a sequence-to-sequence model which takes the body of a GitHub issue and tries to predict its title, a short sentence to recap what has been said in the issue, right? So we're not going to focus that much on the model itself. It's something that I think you all know very well. We will try to focus on building a machine learning pipeline from A to Z that will enable you to, train the model, serve the model, and consume it from an application, right? Kubeflow is open source. So as I said, it runs everywhere. It runs everywhere where Kubernetes runs. So you can run it on Google Cloud on GKE, Google Kubernetes Engine. You can run it on AWS, on AKS. The community is open. They're open to new ideas. It's a tool that is very fast evolving with a target to become an enterprise-grade tool rather quickly. I would say probably sometimes early next year, in the first half of the year. So the problem you're facing, I think you're all facing this, is to move forklift code, machine learning code from development to production. You don't want to have to rewrite everything every time you write some code that runs and trains nicely. You don't want to have to rerun it to deploy it in production. And the solution that Kubeflow proposes, it's to have a packaged infrastructure made of components that you can bind together. You separate the concerns, you focus on each problem, each step of the pipeline, and then you package these together and you deploy them everywhere. Because the challenge is that when you run machine learning code on your laptop, is not the same thing as running it in a data center, where you probably want to run, distributed training on 32 GPUs or 120 GPUs. So the constraints are fairly different from your, code that runs fairly well on your laptop. Machine learning is complex, especially the pipeline is complex. We'll go into that into more detail. And the solution to this complexity is, as I said, to provide you a set of components that you can easily articulate together to build your pipeline. So when I was saying that machine learning is complex, is that the perception of machine learning is the model, right? And there's a bunch of other stuff there that you need to worry about, but what attracts interest to the field, is names of convolutional neural networks and generative adversarial networks and Muscar CNN and stuff like that. But that's the modeling part. But actually, when you want to run your pipeline in production, the model is probably 10% of what you need to worry about, right? Because you need to worry about data, you need to worry about features, you need to worry about analysis, model analysis. You need to worry about infrastructure, accelerator, hardware accelerators. You want to use GPUs, and then monitoring, and there's a bunch of things, right? So if we look at quickly at a typical machine learning pipeline, probably it will not encompass everything you may think of, but I think we have here the basic steps. The first one is you need to gather the data. If you don't have data, you don't have machine learning, right? So, and it's not just ingesting data so that you can train your model. You need to go through data validations, because your model will be retrained frequently in production, every day or every week or every month. And before training your model, you need to check, is my data distribution still the same? Do all the assumptions that I made when I built my model in my development environment based on historical data, do all my assumptions hold when I try to retrain on new data that comes from the real world, right? So you need data validation. You need to transform data, because when you pull it from your operational systems, it doesn't go like this into a machine learning model, right? And of course, you need to create your data sets, training, validation, test. So that was the data part. Now, to train your model, you need features, right? So feature engineering, you do, bucketization, you create embeddings, stuff like that. And you need to be able to do this, chain all these operations one by one every time you rerun a training. And the training is not just training my model, right? You train your model, and your new precision recall, the metrics you're using is 89%. Is that good or bad? Do I put to production or not? So you need to do some model validation. Also, you want to understand, if your model has bias. So probably you want to, most probably you want to do a model analysis, right? So you look at how your model metrics perform on different subsets of your data. And guess what? In production, you need to do distributed training. You need to be able to run it on multiple machines, make sure it doesn't crash, and funny things like that. Then a model that has been only trained is practically worthless if you don't do anything with your prediction, right? If you don't integrate it in an application that you can derive business value out of the prediction of your model. So that means you need to build an application, probably something with a UI that will call an endpoint where your model serves predictions. And all of this, you don't do it in thin air, you run it on a platform and in production. So this means that you need to worry about funny things like authentication, logging, monitoring, CI/CD, all the stuff that it's it's nice and makes the work very interesting. No, I'm joking. But security is not nice. It's a pain. As I said, there is all this complexity, and with Kubeflow, we want to solve it through, composability. I already said it 10 times, right? And we'll look at what components you can build so you can run your pipeline. And also, from the fact that you are building components, you can also reuse them. So next time, you don't need to code anything from scratch. Then you need maintainability, right? So you have a problem in production, or like a customer says, someone from business says, hey, this prediction is wrong. Okay, so how do I troubleshoot this, right? How do I understand why this prediction is wrong? So how do I trace basically how this model has been trained, from what data, making what assumptions, so I can, understand why exactly this prediction was wrong. And I need, once I figure that out, I need to quickly be able to reiterate everything if I need to retrain or something, and deploy the new version in production, right? So again, using components usually helps that, right? And the last thing, when you train a model versus when you serve a model, you have completely different usage patterns in terms of resources. Like when you run a model, when you serve a model, probably you will have spikes in usage, because at some point, there's Black Friday coming, so you're going to have a lot of hits on that day, and probably it will go lower afterwards. So you need an infrastructure that is able to scale up, to absorb spikes in traffic. While when you train a model, the resource usage is completely different. Probably you need, 16 nodes with 8 GPUs each for 12 hours or 24 hours, right? So you need something that is able to provide you that flexibility to adjust your resources and allocate them as you need, depending on the activity that you're doing. That's why Kubernetes, right? That's why Kubeflow has been built on top of Kubernetes, because basically you don't need to do much. The underlying Kubernetes framework is just managing these resources, and you just tell it, okay, give me 32 GPUs, right? And also, Kubeflow's goal is to make it, to be usable and to be used by everyone, right? You don't need to be DevOps to be able to use it. You can be a data scientist, a data engineer, a DevOps person. It doesn't matter. It's supposed to be easy to use, portable and scalable for everyone. So in Kubeflow, like I said, the entire stack is portable. So from the infrastructure to the model to the application, the scalability is embedded into Kubernetes, so you don't have to worry about that. You have one tool, Kubeflow Pipelines, to run all your machine learning process. You can do all your product lifecycle, so development, testing, production, and you can use specialized hardware, right? GPUs, TPUs. You just need to ask them to Kubernetes, and it's going to give them to you. So as I said, Kubeflow is intended to be for everyone. The current release is 0.6.2, so you can see it as a collection of portable components that you reuse to build your pipeline. And it's there to provide you that platform to run your machine learning pipeline, so you don't have to worry about things like, how do I get my GPUs and things like that. Also is based fully on Kubernetes, as I said. So you have operators for distributed training inside Kubeflow. You have all the notions and all the patterns. You can reuse them from Kubernetes, for managed infrastructure, for microservices. There is a packaging framework that's open source that's used to package the builds and transport them from one environment to another. And you don't always have to use TensorFlow. You can use PyTorch or Scikit or XGBoost or whatever you want. As soon as you can, as long as you can package it into a container, it runs on Kubernetes. Disclaimer: the demo will be in TensorFlow. So, sorry. I would say, can you containerize it? If yes, yeah, it runs. I don't have much experience with R, to be honest, so it should be, yeah. You'll see. So when I'll demo the pipeline, you'll get a better understanding what you need to have it running with R. I hope. So for the next, let me check my time. Okay. For the next hour or so, I go through a code lab. So if you want to note it, to write it down, the code lab is available on the Google developers website. I strongly encourage you not to do it in the same time as I'm doing it, because it takes quite some time, right? And you may hit some problems, like, do you have all the rights on GCP to create the Kubernetes clusters and so forth? So I suggest you write it down, and you can play with it whenever you want, and I will try to do it in front of you. Fingers crossed. This morning it worked, right? So I still hope it's going to work. Okay, so let's do this. First thing first, I need to create a Kubeflow cluster, right? Basically, it's a Kubernetes cluster with a ton of pods running into it. There's a very simple interface. I'm going to demonstrate for Google Cloud. You just enter a few informations, and automatically it deploys it creates a cluster inside your a Google Cloud project. Okay, so I'm going to start with that. So I have here a ready Google Cloud project. So I need the project ID. I will call my deployment Kubeflow code lab. Sorry. I will log in with GCP IAP. So just so that IAP is an identity-aware proxy. It's what helps to manage authentication through a public endpoint on Google Cloud Platform. So Kubernetes Kubeflow integrates nicely with that and provides you the authentication mechanism and security mechanisms provided by Google Cloud, and same is on AWS. So I have everything I need here. Now, please don't look, because this is OAuth user and secret. I should have made it black on black. Okay, and I will install it in Europe West 1B, version 0.6.2. Okay, so now the deployment has started. I'm going to explain you very quickly what is going to happen. So this is going to take about 20 minutes, and I will take some time during those 20 minutes to give you more details about the pipeline that we're going to build. And fortunately, if everything goes well, after I tell you everything about the pipeline, the cluster is up and running. Fingers crossed. What is going to happen is, so I'm on Google Cloud. Are you familiar with Google Cloud? Yes. Perfect. Kubernetes engine, as the name says, it's the managed service to run Kubernetes clusters. Now in my project, I have no cluster, and my expectation is that Kubeflow will deploy a Kubernetes cluster. So it's in progress. The way it will deploy it, this is still a Google Cloud feature. It will deploy what's called a deployment manager configuration. So actually there's a ton of things that are happening behind the scenes. There's the Kubernetes cluster that is being created. You have some firewall rules that are being also created so that you can connect to your cluster through the identity-aware proxy. There are some service accounts that are created. So this deployment manager configuration packages everything for you and ensures that if you go and delete your cluster, if the deployment manager configuration is still active, it will recreate your cluster, right? So that's the goal, to do it this way. Okay, so the cluster is going to be it's deployment in progress. So we'll leave it install the cluster, and I will move to another Kubeflow clusters that I have running, so I can show you the pipeline that we're going to build today. So if you look in the URL, it's from Cloud Next London, which was yesterday. So I'm cheating because I ran the same demo yesterday. Anyways, okay, the resolution is not great, but let's try to do this. So this is how you can see the pipeline that you build in Kubeflow Pipelines. So it's a web interface, and you have the steps. Okay, so you have first is the copy training checkpoint step. Why do we do that? So imagine that you do transfer learning, right? So if you do transfer learning, you start from an already trained model. Let's say, I don't know, ImageNet, and then you want to build your own classification of objects because you're not happy with the classification that ImageNet provides. So what you do is you take the model until the layer before the last one, the one that generates the embeddings. You take it as a TensorFlow checkpoint, and then you build on top of it, your classification layer, the last one, with your classes. Okay. So we're going to do something similar because we don't have too much time and the model takes a long time to train. We're going to start from an already saved TensorFlow checkpoint. So the training will be quick compared to what it should take in reality. So the first step is to copy that checkpoint from TF Hub, from TensorFlow Hub. So TensorFlow Hub is a open library of TensorFlow models. And we'll copy it on a Google Cloud storage bucket. And then the training will start from this checkpoint and we'll finish the training. The second step, okay, is called log metadata, right? So I told you about troubleshooting when someone asks you why this model that's running in production gives a bad prediction. The way Kubeflow tries to solve this problem is by providing you a metadata store where you can log information about each step of your training, link each step in what's called a run, an execution, and group multiple executions into a workspace. So this will provide you valuable information regarding lineage, for example, right? So you know that you will know by logging this metadata at each step, you will know that my model that is version 0.1.17 in production has been trained on this data coming from those BigQuery tables, for example, with this query, and I did those transformation, etc. Right? So at every step in the training, every meaningful step in the training, of course, you can log metadata for the current execution of the pipeline, and this will give you the lineage, right? So you should be able to tell provide all the action that have been taken to train that model and push it to production. Of course, after copying the checkpoint, we're going to train the model. So the outcome of that training is another checkpoint. And of course, again, we will log some metadata. And we will say, okay, now at this step, I trained a model, and this is where I put it on Google Cloud Storage. This is where the model lives. And you can link it through the run identifier, and through the workspace, you can link it to the previous step, which is copying the checkpoint. After you train the model, you want to serve it. So everything happens inside the Kubeflow pipeline cluster. If you want to use for training something else, like SageMaker or Cloud AI Platform, so these are managed services for running machine learning training jobs, or if you want to run the training in your own cluster, in your own Kubernetes cluster, you just, from the training step, you just write a component that launches the training on that remote place. So you don't have to run everything in your Kubeflow cluster, right? So many people use the Kubeflow cluster for orchestration, for workflows, for experimentation. So I'll demonstrate you the experimentation feature, which is quite nice, and prefer to run their trainings elsewhere. That's perfectly feasible. Again, you can serve, so in this example, we're going to run a pod, a TF-serve pod inside the Kubeflow cluster that will publish an endpoint that can serve predictions of this model. Again, you can install your model, you can deploy your model everywhere you want, right? And then, based on a condition, we will deploy a web UI, which will allow us to consume the predictions, to make predictions using the model we trained and we served, right? So this is a classic, it's a super simplistic machine learning pipeline, but imagine that you can have whatever steps you want, right? Data ingestion, data transformation, data validation, training, model analysis, model validation. You can have everything, right? So I talked about the application. So let's see, what the end result is supposed to be. Okay. Oh. So as I said, GitHub issue summarization. So we'll enter here the description of a GitHub issue, and we will try to run the prediction and see what the title comes up. Okay. Oh, conveniently I have a GitHub issue. It's from TensorFlow. Okay, so it says, using skip on a dataset that contains corrupted data and then applying ignore errors causes feed method to hang before the validation step. The feed method uses dataset for training and validation. Okay, so believe me, I clicked on the button, something is happening, right? Oh, here it is. So the title is validation error handling. Not that bad, actually. And the actual title is use skip ignore error cause training hang. Machine learning, right? It cannot do better than the data you give it. So. Cool. So where were we in the deployment, right? So as you see, it already tells you, I created an endpoint, and that's the endpoint published by the identity-aware proxy on Google Cloud that exposes the Kubeflow UI, right? Let's go quickly to see how, my cluster appeared. So this is what the installer created. And if I click on, so I have a nice cluster with 2 nodes. By the way, is it too small? Do you want me to? Okay, it's too small. Is this better? Perfect. Okay, if some people in the back say yes, then I'm happy. Okay, so there are 2 nodes. Cluster is up. Let's see the workloads. Okay, so you have a ton of workloads. That's a ton of pods that are running that have been deployed by Kubernetes, by Kubeflow. Not all are working, of course. You know, probably you recognize Katib to do a hyperparameter tuning. What else is interesting? Yeah, NVIDIA driver installer if you want to work with GPUs. And you have also operators for TensorBoard, TFJob, and PyTorch. PyTorch. I said not only TensorFlow, PyTorch also. Okay, so I have the URL. Okay, let's try to access it. Okay, it's still getting up and running. Okay, so what I'm going to do next, I'll wait for the cluster to pop up. And I'll try to walk you through the code that we wrote to build this pipeline, right? And as soon as the cluster finishes creating, then we will demo it. So now I'm on another cluster that I have running, so please bear with me for a moment until the other one is created. One cool thing that you have in Kubeflow pipelines is you have Jupyter notebooks, right? So you can create your own Jupyter notebook server, and you know, you can do very nice notebooks, run them inside your cluster. Of course, you're not forced to run them in your cluster. You can run them anywhere else. And like this notebook demonstrates the pipeline, which is this one, right? So I'm going to go through the Python code that we wrote to create this pipeline. I'll first go through the components because that's the most important part, and then we'll see if my cluster is up and running. Okay, so the most important thing in the pipeline are the components. So a component does one step, executes one step in your pipeline, and you have basically 2 ways of creating a component in Kubeflow. So either use the container op constructor, which basically, as its name says, it allows you to create a container and run it on Kubernetes, right? So, you know, you can say, this is my image, run this image with I don't know how many workers, how many GPU resources. You can specify this kind of resources, right? So it becomes completely transparent for you how those resources are allocated, or even how Kubeflow works. Right? You don't need to write the manifest. It just creates for you a container and runs it on the Kubernetes cluster. So we use container op for model serving and to serve the model, and to run the front end, the web front end, which is this one. And you can also create your own reusable components, and there is one here which is of a lot of interest, which is log metadata. So basically, you're calling the same component twice because you want to log, it's basically you log the same information only on 2 different objects. So you don't want to write your Python code 10 times to log the same thing. So the way to do that is by creating your own components in a component definition file. So let's have a look at the one for the metadata component. Well, not very fancy. You have the image, what Docker image you need to run with what parameters. So here you have, as I mentioned, the run name, the execution of your pipeline, the identifier of your execution, the workspace, and the data URI and model URI. So where I saved my checkpoint at the start of the training and where I saved my model at the end of the training. And of course, log type in this case is either model or data set, right? So if we look at what information can you log about the data set, so here is the schema of what you can write in the metadata database with regards to your data set. I will make this larger. Okay, so you can track things like where is the file that contains your training data, and something that I find very interesting is the query that you used to extract that data if you're using a SQL database. Also, the time, who's the owner. So those are crucial informations about how your data was collected to train your model, right? So this is the first thing you want to know when you're wondering why that model in production version blah, blah, blah is giving that prediction. It's like, how was the data collected? You have here the information. I love this. It's amazing. I mean, I'm excited because, these are simple questions, and for I don't know what reason, it's so difficult to answer them. And like this metadata store, which is not TensorFlow dependent, you can use it with absolutely every framework you want. It provides you a very simple way to retrieve lineage and information like this. So just want you to have a look quickly at the model. So this is the model metadata that you can write. Where is the what kind of model type, training framework, hyperparameters. This is great. This gives you exact information on how you train the model. Again, owner information, creation time, whatever annotations you want to add. Where is the model? The URI. So in the case of the metadata component, you create your own reusable and you call it as many times as you want. And then there are two other components defined like this: the data copy, the component that copies the checkpoint at the beginning of the training, and the training component. So each one has its own component definition file. Again, what image am I going to run with what parameters? Okay, so this is the component that copies the checkpoint. I need to know where is the checkpoint directory, where is the data directory, so I can copy it. And for this workshop, of course, all the containers have already been built. We're not going to build Docker containers here, but just if you want to look what does it look like. So source code, simple Python function that copies all the files from one cloud storage bucket to another. And then I have a basic Docker file. I'm installing, starts from the TensorFlow image. It's installing Google Cloud tools because you're going to use GSUtil and things like that to copy the data. And the final container file that actually builds the containers, it's using the previous, the base Docker, and just runs, train model.py, which can, if you run it with different parameters, will copy the checkpoint or run the training, right? So the actual training is in the same file a bit below. So we were lazy in this case, so we just ran T to T trainer, so it's from the Tensor to Tensor framework. So like I said, we didn't focus now too much on writing fancy TF estimator code. We wanted to have something up and running. But if you're interested, like, this is code you're very familiar with. As long as you can Dockerize it, you can write on Kubeflow pipelines. Okay, so I will give the deployment another look. Okay, expected time remain 14 minutes. Okay, let's see how all my workloads are. Okay, if everything is green except this one, that one always red. I need to understand why. Okay, maybe we can try now to, hey, we may have a cluster up and running. Awesome. Okay, so I will go back to the installer. I have my, great. Okay, so just to, so you're sure that is the one that I just created, look at the URL, it says ODSC London 2019, right? So it's the one I just created. I'm so happy. Okay, I can close everything else for the moment. A bit of housekeeping first, right? So this is the Kubeflow UI. You have your pipelines. Inside the pipelines, you have experiments. Now, this is a very nice feature because it helps you group several executions of your pipeline and compare the results. There's compare runs button on top, right? So you want to understand between two different runs that give probably different results. Your model has different performances. You want to understand what's different. Okay, so you can compare all the parameters you used to run those pipelines and see where the difference comes from. Then to go back, you have Jupyter Notebook servers. And last, you have the artifact store where you will find information about the metadata that we just logged. So you have also a nice visualizer that lets you see the metadata that you logged during your pipeline. We will use for this training a GPU. So for the moment, my node has, my Kubernetes cluster has only 2 nodes, and none of them has a GPU. So what I'm going to do next is I'm going to create a new node pool with 1 node with a GPU, so we can run the training. Okay. So first thing first, I'm going to run a Cloud Shell. So Cloud Shell is a small VM, Linux VM in Google Cloud that has all the G-Cloud tools that allow me to interact with all the Google Cloud services. Probably this is, again, too small. Is this better? Okay. Okay, thank you. Now, if my commands have 10 lines, don't worry, it's normal. Okay, so I will create some variables and configure my G-Cloud commands. So my deployment name is called Kubeflow Code Lab. That's the name of the cluster. My project, a Google Cloud project. I will run everything in Europe West 1B. Then let me see if I have this bucket. So I need a Google Cloud Storage bucket where I can store my checkpoint and my model after the training. So let me see if this already exists. Yes, it does. Perfect. Then I will configure kubectl to work with my Kubernetes cluster. So this is a gcloud command that gets the credentials for my Kubernetes cluster that I just created. I will set the default namespace to Kubeflow. Okay. So let's have a look at nodes. So I'm expecting to have 2 nodes up and running. Nice. Now, I need a node pool with GPUs. So I will do something else first. I need to set the right access rights to the pipeline runner service account so I can do everything I want in my cluster for the moment. And before creating the node pool with GPUs, I will activate auto provisioning, and I will tell you in a bit what auto provisioning is. So what I'm saying is to the Kubernetes cluster is that, you know, if you need to scale up to create new nodes because the pods, you know, I need to run new pods and there are not enough resources, it can scale up to 48 CPUs and up to 24 GPUs, NVIDIA Tesla K80. So that's a very nice feature that will help you provide the necessary resources without having to have them all up and running all the time, right? If GPUs are expensive, we all know that. You don't want to have, you know, 16 nodes running all the time. So auto provisioning will create new nodes automatically when you need them. So I'm ready now to create my node pool. And I will ask my node pool to contain 1 node, machine time N1 high mem 8, so that's like 8 vCPUs, 64 gigabytes, something like that, with 1 Tesla K80 GPU. Okay. Once I have this node pool, I can run my pipeline. Sorry, my training. The pipeline per se doesn't need GPUs, but the training step does. So let me go to the dashboard. Okay, so I only have the demo pipelines configured there. So next step is to upload the pipeline that we just saw, right? So how does this work? I'm using upload by URL. In the notebook, I will demonstrate how to upload it programmatically, like by calling an API. I will call it, I don't know, GitHub issue summarization. Upload.
Sorry, question.
Yes.
What are you uploading the pipeline? What is it?
Right. So that was my next. Thank you for the question. It's a very good question. Okay. So it's a tar gz file. Okay. Actually, I uploaded this. So the pipeline, I wrote it in Python with a DSL provided by Kubeflow. Then there is a step of compilation of the pipeline. So the compilation step actually takes the pipeline and generates a YAML file, this one, which is an Argo YAML file. So Argo is the Kubernetes orchestrator, right? Nothing fancy. You could even write this by yourself. But, you know, if you have something that does it for you automatically, it's much nicer. So the pipeline is there. Let me see if okay. So I should have okay. So my cluster, does it have a GPU node? Yes. So now I have a new node pool called GPU pool. And inside this pool, I have a node with one Tesla K80 GPU. Yes, here it is. Nice. So we can run the pipeline. First thing, I'll create an experiment. Okay. From the pipeline that I just uploaded, I will call it run 01 because the first one today. I just need to specify some parameters. So the first one is my project ID, which is this one. Okay, I have it here. Project ID. I don't need this. And my working directory is my bucket. So my bucket is called cut storage. Okay, this one. Okay. So it's GS my bucket. Now, the checkpoint that we're going to copy is in a public bucket. So that's where we're going to copy it from. And the data on which we're going to do the training is on a different public bucket. And I can start the pipeline, okay? So the next thing that will happen is we'll go into the pipeline, into the run actually, and we will follow the execution in real time. So the first step is currently being executed. Okay, step is pending with message container creating, fair enough. Okay. We need to wait a bit until the container has been created. Let's go in the meanwhile back to the pipeline. Sorry, back to the notebooks. And I will create, to save time, a new notebook server, right? And you can even bring your own image. You can say how much CPU, how much memory you want. We just want a very, very small notebook server. You don't need for much. Okay. So being what happened? I thought I lost internet for a moment there. Okay, so I have one run in progress. Okay, so no, I don't think I can increase these, so you'll have to believe me in the back. Basically, the first step is running, so you can see all the files that are being copied from the bucket containing the checkpoint to our bucket. So you can, there's model.ckpt files. You recognize them. Those are TensorFlow checkpoint files, right? Okay, so this is going to run, and then we will start the second step, which is training and also logging the metadata. In the meanwhile, let's see. Okay, my notebook server is currently being created. And as soon as my notebook is done, I can upload my notebook and we'll continue demonstration there. Okay, so my first step finished. You can see, again, probably too small for the people in the back. You can see the input and the output parameters. So every, in your pipeline, you can pass parameters from one step to the other. So you can, in one component, you can reference output parameters from a previous component. Like, for example, where did I copy my checkpoint? That's useful for the training step. And the input parameters are, checkpoint directory and the data directory. Okay, log metadata. Again, it's waiting for a container creation. How is my... Okay, my notebook server is up and running. So I will upload my notebook. Okay. Is it still too small? Oh, okay. Okay, so again, the components that I just described. A few lines to load each predefined component from its file. And now, let's go quickly over the code that creates the actual pipeline, right? So I will create each step one by one. So the first one is, copy the data. It's created from the copy data component that we loaded from file, and you pass just the input parameters that it needs. You can also pass run information, like dsl.run ID placeholder is the information that will give you the current run of the current execution of the pipeline. So that's super important when you want to log metadata, for example. Or when you want to create, like here, we want to create a special dedicated folder on cloud storage for my run. So having the run ID is super useful. Then I will create a log dataset step from the metadata log component. I would say I want to log information about a dataset with the log type. The workspace, I give it a name WSGH_sum. Also, for logging purposes, the ID of the current execution and the data directory where the data has been saved, the TensorFlow checkpoint. Then there's the training step, which is created from the train component that we loaded earlier. So what I was saying about passing information from one step to another, so you can use here we want to use the copy output path parameter of the copy data step to say, okay, so you start from that checkpoint that is saved there. So if I use the name of my step.outputs and I pass the name of the parameter, I can fetch a parameter from a previous step. Again, a log step, and now it's log model, so I'm logging information about my model. And the serve step. So for the serve step, we're using the container op constructor. So basically, we're telling Kubernetes, run this container. Pretty straightforward. You just tell it the image. Now, again, the image is already built, but if you want to have a look at the Kubeflow manifest, actually, it's what we're doing here is we are running. Okay, let me zoom. It's pretty straightforward. So we are running the TensorFlow serving image, right? And we're saying, oh, here is where the model, saved model is, and you serve it on this port as a REST API, right? So again, pretty straightforward. So we define the serve step, and in a few lines, now you just link the steps together. So you say that log dataset comes after copy data, log model comes after train, of course. Then I need 1 GPU for my training. You don't have to know anything about Kubernetes manifest to do this. You just need, I want 1 GPU and I want 48 gigabytes for my training. And again, at the end, well, if my condition says launch the web app server, the server serving the UI for predictions, then again, I will run another step which I create with container op, which is running this image that we also pre-built. And if you want to have it a quick look, it's a Python Flask application, nothing fancy. It just knows, this is the URL I need to call to get my predictions, and the host, like the server and the servable name, are read from 2 environment variables. Okay, and with this, you can do everything. Let's quickly go back to the execution of our pipeline. Okay, so the log metadata finished. So if everything went well, in my artifact store, yes, I have information about my data set, which I just logged. It's basic, like you can find the run information, the workspace, which regroups several runs, and where my model checkpoint has been saved. First metadata log, and the training is in progress. So this is the training step which is in progress. If we look at the logs, we are at step 2 million something. It's running, and in artifacts you will soon see from this training step a launch TensorBoard button, and you should be able to run TensorBoard while the training is happening. TensorBoard will run in the same cluster, and it will of course read all the event information from cloud storage where the training is saving that data, and you can follow your model performance metrics while the training is happening, right? So okay, let's go back to experiment, run. Yeah, okay, it needs a bit of time. It waits for the first eval step. Let's go now back to the code. So where were we? We coded basically our pipeline. So it's your pipeline is a simple Python function. You just use some Kubeflow DSL, and basically you saw, like, you just connect containers, basically, right? So you can do everything you want. Now, this is a fairly, let's say, generic way of doing things, but because it supports anything, any framework, any any kind of data pipelining you want to implement, but there are ops for when if you want to do distributed TensorFlow. Like there are ops for MPI, there are ops for PyTorch, so that again makes your life much easier in terms of code writing. Right? You won't have to build containers every time. So, running the pipeline, I uploaded in the Kubeflow UI a tar.gz file, which is actually my pipeline compiled. So transformed from Python to an Argo definition file. How do I do this? Well, I have a client. I have a compiler package in Kubeflow Pipelines, and I just call compile with the name of my function and the output file. And if I want to output this pipeline into my Kubeflow cluster, I just need to call client.upload pipeline with the name of the compiled file. So let's run this. Yes, of course. I forgot the most important thing, to run my so please bear with me. Let's go back to the training and see, okay, how my training goes. Okay, so we are at the eval step, so hopefully after the eval step we will see a tensor board appearing here. Okay, import KFP. Now let's load the components. Ooh, something happened. Unexpected keyword metadata. Nice. Okay, let me switch. I'll show you on the other cluster. I don't know what problem this notebook has, but in the interest of time, okay, I already have a notebook server running in my namespace. Okay, passed, run, create the pipeline. Okay, so clear. Oh yes, of course. Error handling is not the best. Okay, so we'll call it ODSC pipeline. Run again. Okay, so in response to my call to create the pipeline, I have all this JSON that describes my pipeline, and I have this super important ID information that I will use it to run my pipeline further down the road. Okay, so now I can create an experiment with the same client object. I will call it experiment. Let's run this. Okay, so experiment link here. Experiment created. And now let me copy this ID. Okay, let's check that we have the pipeline. Pipelines, it's here, ODSC pipeline, the one that I just uploaded. And I will run my pipeline in the experiment I newly created. So run link here. Okay, it's called run for. So if I can go, I go in experiments. I'm an experiment at ODSC. This is my run. So it's done. I mean, it's doing exactly the same thing as I did before, just now, I triggered everything programmatically. So what does this mean? Is that you're in production, you can schedule your pipelines, right? You can schedule you don't need to go on the UI and click on the button run. Like you can do everything from your whatever scheduler you're using, Airflow or anything else. So let's go back to the training that was, did you see it? Start TensorBoard. That was the moment I was waiting for. Okay, so start TensorBoard, open TensorBoard. You see TensorBoard is accessible through the same identity-aware proxy URL on the top. So you have the Kubeflow Pipelines UI, you have the web application that is exposed through the same URL, and now also TensorBoard. And you had nothing to do, just run a pipeline. So if I check my pipeline is finished, web app deployed, so I am on the cluster that I just created. Now I want to check that my web app has been deployed. However, before I see that the log metadata, the second log metadata step has executed. So I will check in my artifact store what appeared, and I have the second artifact, which is my model metadata. Again, very useful information, the execution ID, the workspace, and the training data. Sorry, the path where the model has been exported. So let's go back now to the pipeline. I would love to see TensorBoard. Hey. Okay. Nice. Probably not the nicest learning loss curves you ever saw, but the point is that you have all these components working together to help you, seamlessly and without too much effort, run a fairly complex machine learning pipeline. So the other one that I just ran programmatically is, running, and it's doing exactly the same thing as this one. So I'm going to we're not going to follow this any further. The last thing I want to check is experiments. My run, the first one today. Okay, my web app has been deployed, so the URL should be something like web app. Right. Now, let's take the... Okay, so this is a different training, right? Probably we get a different result. That's going to be fun. Okay, so we're taking the same GitHub issue, and we'll generate the title. I'm going to do the wheel. Oh, I think it's the same. I don't remember. Anyways, that was the small, fairly small Kubeflow pipeline demo. A real machine learning pipeline in real life will be much bigger. But I hope you have all the elements you need to imagine how you would build it from components and how fairly straightforward it is. I'll go back to my presentation for the last 10 minutes, 5 to 10 minutes. So we went to, setting up the environment, create a Kubeflow cluster. We run a pipeline from the dashboard just by clicking. We run a pipeline from from a Jupyter notebook in a programmatic way. Cleanup. Let's do cleanup while we're here. So I was mentioning deployment manager on Google Cloud. So you see two deployment manager configurations. One for the storage, because we want persistent storage for our Kubeflow cluster, and one for the actual Kubeflow cluster. So it's easy. You don't go and kill your Kubernetes cluster. Please don't do that. Just delete nicely the deployment manager configuration, and it will clean up everything that has been installed, like the Kubernetes cluster, firewall rules, service accounts, everything. So it's the very nice way of managing things on Google Cloud. So at the end, I just wanted to give you an insight of what's under the hood. I think we touched upon many of these things. So you have an ingress point. So you have a proxy that is managing all the access from outside your cluster to all your UIs, be it the Kubeflow Pipelines UI, TensorBoard, or a web app that you would deploy in a cluster. You have the dashboard with pipelines, with notebooks. Argo is the interface and the tool for orchestrating the steps of the pipeline. Katib, you can use it for hyperparameter tuning. You have operators for different frameworks, PyTorch and TFJob, so you can run directly code for those frameworks on your cluster. If you don't have those operators yet, build a container and you run everything you want. And for serving, like we demoed, you can either use TF serving, just pick the name of the image, where the model sits on cloud storage or wherever it is, and the port number, or if you want to serve something else than TensorFlow, then you can use Seldon. The community, so Kubeflow is open source. It's a very vibrant community. It's going to be, so the current version is 0.6.2, and the goal of the team is to make it enterprise ready and do it very soon, because clearly there is need for such a tool and an enterprise readiness level tool. Things like handling authentication, handling logging, alerting, monitoring. These are the kind of things that enterprise products are really. So those are the things that make a product enterprise ready, right? Basically, Kubeflow has been around for probably almost 2 years now. Every component in the tool has been around there for a long time, but making enterprise ready is providing that quality that helps you, troubleshoot your problems whenever they appear and integrate seamlessly with the security of your system, and things like this. So if you want to contribute, the community is open and very, very, very in need of new ideas and contributors. So please don't hesitate. And that was all from me. I think we finished 11 minutes earlier. So do you have any questions that you may not have asked so far? Yes.
Why was the provisioning of the Kubernetes cluster so slow compared to the adding of the GPU node?
Oh, a very good question. So the provision of the cluster was fast. That's not the thing that takes time. What takes time when you deploy Kubeflow pipeline is that actually you create a cluster, you install a bunch of like 50 pods, basically. Not only this, but you create a deployment manager configuration, you create firewall rules, you create service accounts. There is the configuration with the identity aware proxy, so you can access it. So what you didn't see actually is that when I access that proxy, I am authenticated by Google Cloud, right? So if I go, let me show you, if I go on an incognito window, it says bye-bye, I don't know you. So there's a bunch of things that happen in addition to just creating a cluster. There are SSH keys that are generating, and that's not something very nice and fast. Let me try to, because this is very interesting, right? So this is the URL of my cluster. I am authenticated on Google Cloud, and it doesn't work. This is awesome. Sorry. Maybe the slash. I think it's a slash at the end. Oh, yes. Thank you. But I have a different one. It's called next. Thank you very much. Okay, so I am authenticated to Google Cloud, so you didn't see anything like, hey, user password pop up. Okay. Now let's try it in an incognito window. Fingers crossed. Okay. So this means authentication, security, access rights, everything. Okay. Any other questions?
So competitive meeting software such as like
Such as? Sorry?
MLflow,
Okay.
they kind of facilitate collaboration quite nicely. So it appears to me, such as someone can offer to upgrade your model and say, here's how we use some parameters, here's how performance compares to your current model. How does Kubeflow, does it offer any collaboration tools?
Okay, so I think the primary goal of Kubeflow is running the pipeline. There are other tools that provide such functionalities. I can only speak for Google Cloud. So there is the I have a memory lapse. So there is a tool on Google Cloud where you can, okay, there is TF Hub, okay, like to start with, but there is a similar tool, AI Hub, in Google Cloud, which is similar to TF Hub, whose purpose is this kind of collaboration that you describe, and you can also collaborate with pipelines in AI Hub, right? Not only models, like basically you can put any kind of notebook, but
Those features would be outside.
yes, those features would be outside. So on Google Cloud there is like AI Hub that would provide such features. You're welcome. Yes.
During the demo you mentioned you could use other implementations of notebooks besides the
Yes.
Kubeflow implementation, but right now you're behind the scenes is creating, if you go to VI, you create a notebook.
Right.
It's creating a YAML definition for the notebook, which is picked up by the notebook operator. But the notebook operator only creates plots within your cluster, right? It can't create AWS SageMaker notebooks or smaller Linux.
No, I mean, yeah. Well, I mean, I think you can create, as long as you can have the image, you can create it. I doubt you have the image of SageMaker, but I mean, I tried once. So that's in that way it can run any image. But you can use notebooks outside Kubeflow pipelines. I mean, my first intuitively, I wouldn't necessarily go and use a notebook inside Kubeflow pipelines because I consider that as my, pipeline manager tool. So on Google Cloud, you would use something like Cloud AI notebooks, for example, which is probably more focused on collaboration, and there really you can just you see, as long as the image is on Google Cloud, you can run it, right?
And is it then is it on the roadmap that you can spin up those, for example, the Google AI notebooks from Kubeflow?
I mean, I think you can do it right now. It's a gcloud compute command. That's it. So that's very Google specific, okay?
Yeah.
So Kubeflow being open source and its goal is to run everywhere, that would be a feature that would tie it to Google Cloud. So I don't think the team will implement such a thing, but if you want, it's one line of code, right? So you can write Well, I can write your component that does that, maybe, probably. Yeah. Yes, please.
How does Kubeflow relate to TFX?
Oh, excellent question.
Yesterday I attended the whole conference.
Right.
So, well, the impression is that because it says TFX, can use Airflow.
Yes.
Or Kubeflow plus orchestration.
Yes. Yes.
So,
Exactly.
It's easier to say on one side.
So the way I would. Yes. Sorry. What's the thing about Kubeflow and TFX? How they relate? So Kubeflow is for orchestration and for providing you an environment where you can run your machine learning workloads, right? TFX is TensorFlow focused and is for implementing certain steps in your pipeline, right? So you have TFX data analysis, TFX model validation, TF transform, right? So I would use TFX to implement my steps in my pipeline. So for example, to generate my TF records, I would use TF transform, which runs on Dataflow if you're on Google Cloud, right? To run at scale. And that would be one step in my Kubeflow pipeline, right? Model validation, I would use, it's awesome, TFX model validation. It creates that very nice notebook where you can explore, you do feature splitting, I think that's the name. And that would be one step in my pipeline, but I would use Kubeflow to orchestrate my pipeline, right? You can also use Airflow, which is another orchestrator, but it's like the difference is that Airflow is multi-purpose, it's generic. Like Airflow is to do, you should be able to do anything with Airflow. Kubeflow is super focused on machine learning, and like one feature that it's only existing in Kubeflow and it's for machine learning is this experimentation, right? I want to be able to compare my runs, how they perform based on, and understand what the difference in configuration is between my runs, right? That kind of things doesn't exist in Airflow, but you can totally run your pipeline on Airflow, right? And TFX would implement steps in my pipeline. But what I would like to see from like Kubeflow, like in the next versions, I would like to see as I would like it to be as rich as TFX, for example. Like TFX has everything out of the box to run a proper machine learning pipeline. On Kubeflow, you still need to write containers sometimes. And that would be ideal, like to have like the same richness of components in Kubeflow as on TFX. Welcome. Any more questions? Yes. So metadata is as I said, it's not framework specific. It can be either a SQL base, or I mean it's SQL, but it can be either on a file or on an actual database, right? So there's a SQL, there's a MySQL, I guess, running inside Kubeflow pipelines.
tar files? The tar files uploaded?
No, the artifacts, like the artifacts that you can see in the metadata, the things that you're logging. I understood? Yeah. Great. Oh, another question. Yes.
So when you create the models, and sometimes you get like these huge models, right, gigabyte size, or I'm not sure.
Right.
So but is
Right.
it like embedded into the Docker image, or does the Docker image like retrieve the model from storage when it wakes up?
Oh, you never embed them at it. I would never. So you always, when you run the training, you always save the model on a storage somewhere.
Yeah.
So you don't have to embed it in any Docker image.
But when you serve it.
Oh, well, you mean when you serve it? Okay, so when you serve it, you need a big machine, right? So you're running tf-serve, and it's picking the model from a cloud storage location.
On entry, right?
Sorry?
On entry, like when the
When it starts up, and it needs to load it in the memory. So you need here's the thing, you can say to the so you're using container op, and you can say to the container op, hey, I need 200 gigabytes of memory, because I know that I will need to load a huge model. So that should be much easier than going and writing a Kubernetes manifest. Okay, it's time. Thank you very much.